What is the thing I told you are not going to do in this kind of problem? Very good. You're not going to distribute property because it doesn't, it's not stupid, it's just it won't work because absolute value is just different. So what you want to do instead is get the absolute value by itself first by doing what first? Adding the 6. So that gives you what on the right-hand side? Okay. And then you divide by 2. You resist the urge to distribute here. Those are not parentheses. They're absolute value. It's different. Remember, inside the absolute value could be 2 different values, right? A positive version and a negative. So distributive won't work. So instead we do what, Jacob? Divide. Divide both sides by the 2. If you were to try to force the distributive property, is that what you're trying to do? Like we would have to do some other kinds of math to make it happen. Yeah, excellent. I like when y'all go over things again. So then we have this absolute value. Remember absolute value when we started this lesson yesterday? Before I gave you something complicated like this, it was more like this. What 2 things can go inside here so that it would equal 7, right? We said it could either be negative 7 in there or it could be 7. Well, in this case, what's in there? It's the 5x minus 4. That can either equal negative 7 or it can equal positive 7. And so then what we want to know is what x values would make that true, and we solve those 2 baby equations. Does anybody need more time solving the baby equations? Oh, you want to do it on the board? Thank you. Oh yeah, you can do it. Thank you. I appreciate you. We're not graphing these. We will be graphing today with inequalities. It did look like once you clapped, he was just going to sit down, right? Oh, put it on the pen. I'm sorry. It's next to the A, to the left of the A. Yeah. 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 So he's adding 4 to both sides. So 5x equals negative 3. That's good. Gus, I know that, like, you just, we're all friends here, but that sounded racist. Don't say that. X equals negative 3/5. Very good. That's okay. And then do the second equation, too. So now he's adding 4 over there, but that 7 was positive, so we have 5x equals 11. X equals 11/6. All right, thank you so much. Did anybody convert to decimals? I take decimals. It's okay. I don't mind if you put decimals. It's no big deal. So 11/5 and negative 3/5. All right. All right. So inequalities. We're going to do the method pretty much almost like we did yesterday, but when we get our answer, we're going to put it both in symbols and graph on a number line so that you can have a visual of what the solution set looks like. So we're doing those 2 things for the answer. So I said that it's going to work like yesterday in this way. You're going to drop the absolute value bar. You're going to make a negative version and a positive version. So for this example right here, that begins like this. Bars are gone. I have 5x minus 6 and I make the 4 negative, but if you're doing inequality, what happens when you put the negative in there? You flip the sign, okay? Remember, like on the absolute value, we do a negative and a positive version? So then the positive version, nothing will change. You're just dropping the bars. So then what do you need to do to get started for solving? Add 6, right? And then divide by 5. So I have x greater than or equal to 2/5. Remember, it's always opens like a jaw towards the bigger value and points like a judgy person to the smaller value. Or you can just read it. Well, some people can't remember which one is which.
Alligator eats the bigger number. But X is not a bigger number. X is a variable. We don't know that. It's hidden. It's like a mystery. I don't know. I'd rather take 2 out of 5 X is one random number.
So we have x greater than or equal to 2/5 and x less than or equal to 2. If you're graduating this year and you're going to take college algebra at school next year, or you're going to be a senior next year taking college algebra, when we do compound inequalities, it's very important that you can identify which is an and compound inequality and which is an or. And a compound inequality just means one or more, which is what we have here. We have 2. So the best and easiest way is to graph your solution set first, and then decide which is and which is or. So draw yourself a little number line. No, not really. We're finding the solution set for x, but there's no y's. There's no range. You don't have to be real detailed with your number line. You're just going to drop those 2 numbers down on there somewhere. Which one goes on the left? 2/5. And 2 can go over here somewhere. Do these need open or closed circles? Closed, because it has a little wiki right there. It's a closed. It's an equal. Yes. Now here's how to decide which direction you're graphing, okay? This first one, I need everything. Do I need it bigger than 2/5 or less than? What does this mean? Greater than. Which direction is that? To the right of 2/5, okay? And then this is all the x's less than 2. So here's 2. So we need everything to the right of this and to the left of this. Did you hear the words I just said? Did I say and or or? And, right?
So do we just like make a path line?
Yeah. So I want you to put and between those 2 inequalities. I will be checking for this. Yes. Because it's everything bigger than this and also less than that. Yeah, we're going to do that next. So please do example 2 by yourself. Okay. Yes. On the quiz, I'm looking for both of these things. I want both of those. Oh, you mean like those arrows I just did right there? You don't have to do that. I just do that as a process. Yeah. Yeah, yeah. I just do those just to get started on the thing for you. No, you don't have to do that. Okay, what's different on this right-hand side? What's changed? Okay, these are greater thans. Okay? So let's go through this a little bit faster. You ready? You're still making a negative version. You're still making a positive version. You're still flipping the sign when you make it negative. Okay? The graph is going to be different at the end, though. So do your math, and then I'll do my math, and then we'll talk about how it looks at the end. We're doing this one. Look, I already finished mine. You have started. Thank you. You have not started. And you have not started. How are you doing, Frank? Okay. We are doing example 3. I see number lines, that's good. I see open circles. I see some people not quite sure how to shade, so we'll talk about that. All right, which goes on the left, -4 or 1? Do they get open or closed? Okay, so yes, that's exactly right. They're going these ways, because this is everything less than -4, which is to the left. Guess you're not singing my lefts and rights anymore. And this is everything to the right of 1. All right, so do you think this is an and or an or? Absolutely, this is an or, because listen to how you would just say it naturally. You would say everything to the left of -4 or to the right of 1. They don't have any overlap, right? They don't have anything in common. So that's why this is an or. So this is your entire answer right here. The inequalities, the or, and the number line. All right, so do example 4, please, if you haven't already. You have to. We don't have a practice worksheet today, so this is our practice problems. That's why I went to. Well, we have some problems on the back after this. We're out of here at. Yes, there's a back. No. Hold on. Oh, hold on. I'm not to the back yet. Did y'all get this on the front, number 4? Any questions? Okay, so now what was your question about number? Does anybody need this up anymore for another second? Everybody got it? Okay. So there is like, I speak on behalf of the class. We're all good. Okay. So what was your question about 5?
Do we have a negative x and a positive x?
We will have a negative version and a positive version. Real quick, just to set up this problem, this is like a real world problem. This is basically doing the following. Like if I told you, if I said, so this is a different, easier example. I have 25 kids in class, in all my classes, give or take 5. Okay, sorry, 25 kids, give or take 5. What would the lowest range I would have? 20, what would the highest range be? 30, right? So if I said my average class size is 25, give or take 5, it means it could either be 5 below or 5 above. That 5, that give or take 5, is what this problem is talking about as the tolerance. It's the difference you could tolerate in either direction. And this example is like a machinery example. The ideal diameter of a rod needed for a machine is 60 millimeters. Millimeters not very big. The actual diameter can vary by 0.075. What range of diameters will be acceptable to the customer without the rod being rejected? Like, do you ever watch those How Do They Make That show? Or how do they do that? And like sometimes if it's not, like you see them like on the assembly line, they're keeping stuff and they're throwing stuff, keeping stuff and throwing stuff. Because they're trained to know which one would not be acceptable. So they throw that out, they reject it. And so I know that, now here's the thing. I know you can do this problem without setting up the inequality. I know you can do this problem in your head. However, we are going to practice with inequality because that's the skill for the day. So it's not so much about the answer as about setting it up and working with this, okay? So, oh yeah, or you could at least set it up in your head. I mean, it wouldn't be hard. So here's what we need to figure out is, we're given two numbers. We're given 60 and 0.075. Where do you think in this formula that we're given, notice it has an absolute value. 60 goes in ideal, right? So we're going to plug in 60 right there for the ideal part. Where does the 0.075 go? That's the tolerance. That's what it can. That's what it will accept in either direction. It can be either.
Well, yeah. So if it's over, if it's 0.001 over, it doesn't tolerate it.
The actual, it's your variable. Because the actual diameter varies from rod to rod, right? It's producing like hundreds or thousands. So it varies. That means we're putting in a variable, x.
Oh, just X.
It doesn't have to be x. It can be whatever variable you want. Yes.
How many inches is 60?
So then we set up our negative version and our positive version. You drop the absolute value bars. For the negative version, what do I have to be sure I do? Flip this sign. And then you make the regular one where nothing changes. Do your math. Add 60 to both sides. No, there should be no keep changing and flipping. And then I had the question, how do you know if it's an and or an or? Okay, if it's going towards or away. I always recommend, and I do this, and I tell this to my college algebra students as well. If you can't tell automatically off the top of your head, you draw a picture. The picture is the number line, okay? So 59.925 is here. 60.075 is here. We need everything bigger than 59.925 and less than 60.75. Is that an and or an or situation? And. So your final answer in a sentence would be the diameters or the rod diameters must be between 59.925. Don't forget your units on your final exam. Sometimes you get a point just for having the units down. So don't forget them. And I'll talk about that in a second. 60.07. And we'll leave the other word problem for a warm-up tomorrow. It works exactly the same. It ain't no thing.